Hello everyone and welcome to a new HyperWorks tutorial. Today we will be creating beam elements. To begin, we go into File, Open, HyperMesh Model, and we browse to the file associated with this exercise. To view metadata, go to the Post ribbon, to the Query group, and select Matrix. Once the Matrix browser has been opened, populate this browser with the metadata by selecting HMData, Modules, and pressing Query. From the Advanced selection, select the 4 different parts that contain beam sections metadata. By pressing the checkmark, the part IDs will appear in the Matrix browser. Click Modules above and several options will appear in the Data Names window. Scroll down the Data Names window and select Metadata. Now select Beam Section Dimension and Beam Section Shape and press Query. After this, the Matrix browser will populate with the dimensions and shape metadata. Now, open the part browser and select one of the parts under GA Aircraft Lines Assembly. In the Entity Editor, expand Metadata tab and review beam section dimensions and shape. Load a TCL script to automatically create beam sections based on metadata. Go to File, Load, Script, and browse to the script associated with this exercise. Click Open to run the script. In the Mesh ribbon, under the Beam Mesh group, open Beam Sections browser to review the 4 beam sections that have been created. Rename them accordingly. Now, go back to the part browser and isolate GA Aircraft Lines. In the Mesh ribbon, under Beam Mesh group, select Stiffener Mesh. In the guide bar, choose Lines from the drop-down menu, and be sure that Free Lines is active. Select all the displayed lines and choose P-Beam Property from the drop-down menu in the micro dialog. Click the play button to create 1D elements. It is okay if a warning dialog appears. Display 1D beams as 3D elements. Back in the part browser, use Review mode and verify the creation of each beam section type. In the part browser, show GA fuselage elements. In the next step, we will adjust the orientation of the beam sections. Save your model before proceeding with the exercise. Back in the Mesh ribbon, Under the beam mesh group, select Edit Beam. Adjust the orientation of the 4 beam sections with Orient. Following this demonstration, also adjust the position using Offset. Following this demonstration. Review the parts with beam sections from the part browser. Save your model before proceeding with the exercise. You can edit beam dimensions from the beam section browser. For example, if we select beam L, we can change the dimension 1 from 25 to 50 and see the changes in the graphic area. Undo to go back to the previous value. One D beam elements can be transformed into a 2D shell mesh alongside the mesh of the fuselage. Make current the GA fuselage component. Under the mesh ribbon in the beam mesh group, select Inflate. Select the displayed beam elements to mesh, keeping the default options. Uncheck the surface only option. In the micro dialog, select element size 10 and type quad. Hit play to confirm. And the 2D shell mesh is now created for the interior of the fuselage. Save your model before proceeding with the exercise. One D beam elements can be transformed into a 3D solid. Make current and isolate GA aircraft stringer L component. Under the mesh ribbon in the beam mesh group, select Inflate, as shown here. Select the beams to convert to solids and confirm. Use topology visualization to inspect the result. Another method of updating the beam section properties of our 1D beam elements is by extracting section cuts from a solid. This can be done using the Solid Selection tool. Isolate only the GA aircraft fuselage ASCII part assembly and the GA aircraft stringer T part. In the mesh ribbon beam mesh group, select Solid Section. As 1D, select all the 1D beam elements in the portion here. Change selection to solids and select the stringer. Now we can select the location on which the cross-sectional area will be measured. Select somewhere in the middle of the solid, and a red outline will show the cross-sectional area that is currently selected. Under Options, check Create Sketch. By pressing the play button in the guide bar, this cross-sectional area is applied across all the beam elements. Solid Section Property tool automatically calculates the homogenized material properties for the homogenized section. This can be seen in the Properties browser by looking at the newly added material property, which is titled AutoProp 1. Save your HyperMesh model before continuing. In the Mesh ribbon, in the Beam Mesh group, open the Beam Section browser. Select the new solid section and right-click Edit in Sketcher. Use the tools inside the Sketch ribbon to modify the profile of the beam section. It must be a single closed part. Once finished, exit from the sketch editor. The solid section has been updated to the new sketch accordingly. Open the Sketches browser, right-click and duplicate to create a new sketch. Name it New Shape. Right-click and edit to open the sketch editor environment. Create a simple addition to the sketch and assign parameters. Review them in the Variable Manager. Exit from the sketch. The new sketch can be assigned to the solid section created previously from Beam Section Browser. Entity Editor, Advanced Selection, select New Shape, and OK. The beam section will be updated with the new sketch. Open the Variable Manager for further live modifications. Type a new value and press Enter to confirm.